All right. How was your day? Good day? Brain melted a little bit? I know how it is. It's hard to speak, but it's a lot harder to be in the chair learning all day with new things happening to you constantly. So it's hard work. You've done well. Round one is over. Round two, almost over. Round two begins tomorrow. And I would just like to spend a little bit of time together before the end of the night talking about events. Now, this guy, Harold McMillan. Does anybody know the name? Anybody recognize the name? Okay. There's like two British guys. Put their hands up. Harold MacMillan was Prime Minister of the United Kingdom from 1957 to 1963. So before most of us in the room were even born, he was Prime Minister. He was known for being witty and unflappable, and just anything could happen, and he was just this super even-keel guy. And a lot of crazy things were happening at the time. The UK was decolonizing, was freeing colonies and returning them to rule themselves. There was this whole thing that had happened with a war around the Suez Canal. That was this really painful thing between the UK and the US. He kind of helped heal that. So, interesting guy, right? A lot of big things going on. And supposedly, around the time he took office, a reporter asked him a question. And a reporter asked him, Sir, what might blow your government off track? And his answer to that question was the title of this talk, Events, Dear Boy, Events. So clever. You know, it's kind of goals to be able to answer a reporter's question that way. I guess in some sense it's goals to be asked questions by reporters. Most of us never get there, but clever. And I think he rightly pointed to the centrality of things happening. And I spend a lot of my time talking about events, Kafka, and how to build systems centered around events and all that kind of thing. So that just struck me. And you say, but wait a second now, Tim, that's a different kind of event. That's not really what we mean. He means like things happening to a government, and we mean like sensor readings, right? Well, I'm not sure. And I think to answer this question, we have to provide a little bit of philosophical groundwork. That's really what this talk is. It's half, close the doors, it's half philosophy lesson and half software architecture lesson. And I think this is going to be interesting. I'd like to dig into a little bit of what we mean by events. And I want to do that through the lens of four historical philosophers, four thinkers, and see if they lead us to something like McMillan's view that events were central in life. My guess is it's not going to be quite as easy as he thought, but hey, let's get started. And let's set the Wayback Machine to 535 BC. 535 to 475 BC, a long time ago, and a guy named Heraclitus. Now, he was born in the city of Ephesus, and Ephesus is in modern-day Turkey. It was ruled by Persia at the time. So the events of the movie 300, which I think is, if you're like me, how most of us sort of index this period of time, that stuff, the battle at the end of that movie, the Battle of Plataea, that was at the very end of the movie, that took place about 4 years before Heraclitus died. Okay, so just we like to reference things to Zack Snyder films when possible. And that's when Heraclitus lived. So anyway, he was a philosopher. He wrestled with problems of metaphysics, which was common for philosophers of his time. Metaphysics is a study of what is, what exists, and how things that exist have properties and relate to one another. For example, just to differentiate it, it's not the study of how you know things. It's not the study of what's good. It's the study of just what exists. And he was preoccupied with metaphysics. Also, according to some later sources, some much later sources, he struggled with depression. He's sometimes referred to as the weeping philosopher. So I think this was an actual issue that this guy struggled with, still did really important work that made an impact that people still talk about. As far as we know, he was not a distributed systems engineer. That would, I think, be reason enough to be a weeping philosopher, to be called the weeping philosopher if you build distributed systems. Anyway, he viewed the world, he said everything is, oh yeah, by the way, so metaphysics in this era of philosophy in Greece, people were trying to figure out what things were made out of. That's a metaphysical question. And there were 4 options, sometimes 5. Is everything really earth, air, fire, or water? That was the metaphysical question of the day. They would argue about this. So people say, like, no, everything's really water. This other guy would be like, no, everything's really, if you think about it, it's really earth, which seems strange to us these days. But that's okay. They were laying groundwork. And Heraclitus said everything is like itself and its opposite together. And he thought, that's kind of like fire. Fire is like itself and its opposite together. Not clear to me how, but he was one of the guys who thought that everything is fundamentally fire. And fire, what do you know about fire? You watch a fire, it doesn't stay the same, right? If you look at the earth is just constant all the time. Fire is changing all the time. So Heraclitus was this guy who thought that change is the one fundamental thing. The one fundamental thing that's true about everything is change. He's got a famous quote, which is that no one steps in the same river twice. He said, because if you step out of the river and back in, the river has changed. It's flowed, it's different, looks totally different. And you have changed also. So to Heraclitus, everything was change. Everything was events, everything was different all the time. And there was not really a lot of continuous identity. I'm not the same thing as I was 5 minutes ago. The river is not the same thing as I was 5 minutes ago. So he pointed out the centrality of change. And that's a good insight for us to have. So he's our first philosopher. Heraclitus, literally 500 BC, very long time ago. In the category of philosophers we call the pre-Socratic philosophers. A little bit of a bummer if you think about it, right? There are dozens of these guys doing really hard work with very little to draw on, and they all get lumped in this one category of they were before this other real important guy. A little bit of a bummer. But anyway, he was a pre-Socratic, and he showed us the importance of change. Now, does anybody recognize this painting? You didn't think this was going to be a liberal arts lesson. All right, this is called The School of Athens, and it's by one of the Teenage Mutant Ninja Turtles. It is by Raphael. So this is the School of Athens, and it's kind of neat. Pretty much everybody needs to have these things pointed out to them, but everybody in this painting is somebody important, either from classical antiquity or from the period of the Renaissance around when this was painted. So it's all these interesting figures, and it's really neat to dig into. But we're going to focus on these 2 middle guys. There's one guy pointing up to the heavens and one guy saying, bro, bring it down a level down here. And they are, of course, Plato pointing up to the heavens and our guy here, Aristotle, the younger man. He's who we're going to talk about next. So Aristotle was born about a couple of hundred years after Heraclitus, so 384 BC. He died in 322. So that's kind of getting into, a more recent period of Greek history. And he's from the northern part of Greece, not over in Turkey, but over in Greece proper. And he was actually a student. So the reason why those two are shown next to each other is because Aristotle was a student of Plato for about 20 years, starting about the age of 17 and going to his late 30s. He was a student of Plato. This team, Plato and Aristotle, and I said Heraclitus was a pre-Socratic. You have Socrates, Plato, Aristotle. They were kind of the Greek philosophical dream team. They set the tone for what Western philosophy was going to be thinking about, and is still thinking about 2,500 years later, 2,300 years later. Socrates never really wrote anything down. Plato wrote a few things down. Aristotle wrote a lot of things down. He wrote things about the natural sciences, logic, ethics, epistemology, which is how we know things, metaphysics, which is what we're going to talk about, even storytelling. he wrote a book called The Poetics. And the guy who is, I think, arguably the greatest living screenwriter, you can fight me later, Aaron Sorkin. He's one of the screenwriters are not usually household names. He's as close as you get to being a household name. Sometimes a movie will be advertised as an Aaron Sorkin movie because he wrote it. Normally, if you want to know the screenwriter, you have to go on IMDb and click like 4 times to find it. Anyway, he has said that if you want to understand storytelling, you want to understand how writing works, read what Aristotle said. So this guy left a massive impact on a lot of things. And there's no summarizing him, right? Heraclitus was this much more focused guy, and we say, you never step into the same river twice. That was Heraclitus. Okay, moving on. You know, you don't do that with Aristotle, especially in a talk like this. There's no summarizing this guy, because he was just all over the place. What we're going to think about today, though, was his view of metaphysics. And when it comes to, when you think at the top level Wikipedia page summary of Aristotle, and even his Wikipedia page is frankly quite long, what we think of with Aristotle and metaphysics is his view of properties. I'm going to say properties. It's not exactly the word they use, but properties. So we always think of, for some reason, philosophy books always say, think of a red ball, all right? And you're like, okay, that's fun. I could bounce a red ball. Well, Aristotle wrestled with the problem of how does that ball have redness, right? Like, how is that ball red? And you might think, if you've never read a lot of philosophy or thought about this stuff, you might think that is the most ridiculous question in the world. But that ball is red, right? The weird thing about that is that there are other red balls. And all those balls are all red. They all have this same thing, but they're different balls, right? They're unique individuals, but they all seem to have this same property. They participate in this same thing of redness, all right? Now, remember, Aristotle studied under Plato, and Plato had a really hardcore view of this kind of thing. He said, you know what? Redness isn't just this incidental property. It's a real thing. It exists up there somewhere, floating in the heavens in this, the place where all the perfect things are. For Plato, there was this actual place where redness lived, and ballness lived, and chairness lived, and all these things, and actual individual objects are just like these imperfect reflections of the ideal things up in the heavens. That was Plato, right? He had the super hardcore view. That's Plato, by the way. That's backing up, just get the faces right. That's Aristotle, somewhat shorter beard. Plato, longer beard. Okay, you gotta, just so you know who they are. I know they all look alike, but you gotta go by the beards. Anyway, redness, baldness, these were these really robust concepts to Plato, which I'm sure he thought was baller. And Aristotle inherited that. He's like, and remember Plato in the School of Athens is pointing up. That's why he's pointing up. He's like, all the real things are up there. And Aristotle's like, no, some of the real things are here too. And he said, okay, there's all these red balls in the world. And there's this real sense in which red is a thing. And it's a thing that all these balls have, right? In other words, and here's the summary I'm trying to come to about Aristotle. Here's a couple of vocabulary words here. Aristotle is a realist when it comes to universals. I said properties before, like that ball has the property of being red. In metaphysics, we call that a universal. Red is this thing that lots of individual things can have, this general, this universal thing. And Aristotle said that redness, maybe it's not floating up there in the heavens, Plato, where you think it is in this place, but it's a real thing. And to be a realist about universals means to think redness is not just this coincidence, it's not just this label, it's not just this idea that I have, but it's a real thing that's out there that we need to deal with, and it exists in those balls. And a lot of hay is made, like the painting, you know, Plato and Aristotle are disagreeing. But I think what's important, what we ought to take away from him is that he said, at least, you know, when we're thinking about Aristotle and metaphysics, properties are real things. Heraclitus said change is central. Aristotle said properties are real. And again, sometimes we call them universals. And for tonight, I just want you to think of those as being the same thing. Properties are a real thing. It might be a good time to just stop and ask, where do universals live in software? Well, I'm not exactly going to tell you that. The reason for that is I'm not attempting here to give a philosophical account of what software is. I think that's a super interesting question, but it would require that we give like a philosophical account of computation, and that's just a whole lot more philosophy of mathematics than I'm prepared to bring. And by prepared, I mean both what I have slides for and what I am actually able to do. I think it's very interesting, and a few people have kind of toyed with this. But anyway, let's just see if maybe we might back into this question of where universals are in software. Keep it in mind. I'm not really going to give you a closed form definition of that, but the question has come up, and we may come back to it. That's Aristotle. Philosopher number 3. Bill and I are close, so I call him Bill. Most people call him William of Ockham. He was born in Surrey, England, in the 1200s. Surrey is, if you look at London, Surrey is kind of just like southwest, this big kind of area to the southwest of London, so real close to London. He was a Franciscan monk, hence the funny haircut and the clothing. Also, important philosopher, theologian, political dissident. He got involved with some controversies with the Pope and had to kind of move around and find people to give him a place to stay where he'd be safe. It was an interesting time for him, but busy guy and broad thinker. What do we know William of Ockham for? Occam's razor. So Occam's razor, if you want to sound cool, you can call this the principle of parsimony. Sometimes it's called the principle of parsimony, and usually Occam's razor is summarized something like this. The simplest explanation is the one that's probably true, or something like that. You know, if you have two theories and one has got lots of moving parts and intricacy and you need a crazy diagram for it, and one of them's real simple, the simple theory is more likely to be true. Probably also true of software architectures. I've seen diagrams where that architecture cannot be true. Recently, in fact, I can't obviously give you specifics. I'm just remembering a meeting that was a few weeks ago, and it was so bad. There were so many pieces to the architecture, and you don't want that, right? You want probably the simpler one is the one that's going to work. And that idea we owe really to William of Ockham and Occam's razor. We'll come back to Occam's razor in a minute. I think I'm going to give you a new spin on it that'll make a little more sense. Anyway, William of Ockham was a pioneer of something called nominalism. Now, I said that Aristotle was a realist when it came to universals. Sometimes when we're talking about this, we just say Aristotle was a realist. Now, that doesn't mean that he was kind of hard-nosed and he's like, look, I don't care, I know it makes you sad, kid, but you just got to face facts. You know, that's somebody who might call a realist. A realist about universals is a person who philosophically thinks that properties are real objects that exist. William of Ockham was a nominalist, which is the opposite of a realist. It's a person who says that only individual things exist. So there are red balls. Yes, my friends, there are red balls. You can bounce them. You can put them on your Christmas tree. But they are just a bunch of individual balls that all happen to be the same color. And a nominalist has a different way of describing what it means for them to be the same, that color to be the same. But fundamentally, they're all individuals. There are no such thing as universals. There is no red anywhere in the world. They're just these balls. Redness. What is redness? Well, nominalists have a lot of ways of working with this. William of Ockham said it's a concept in your mind. You see things, and they present themselves to your mind as being the same. It's red, it's red, it's red, and all the same color. I'm going to call that red because my friends call it red, and that's just there. So to William of Ockham, that was just a mental concept. And to us, these days, frankly, that makes a lot more sense than realism to most people. If we just took a poll, even if you'd never heard of these concepts before, you'd probably go like, well, obviously William of of Occam is right. Aristotle was Greek. What are you going to do? You know, it was a long time ago. It sounds silly. When you dig into these things, it's usually a little more complicated than that. But William of Ockham is the beginning of the rise and eventual current triumph of nominalism in philosophy. Now, the actual Razor statement is this. So hopefully that's clear. That's Latin. A good English translation would be, one should not multiply entities needlessly. So, applied to software architecture, applied to just kind of general theories about things, that's the same thing as the simpler explanation is probably true, right? But this is a little bit more precise of an account. And when you put it in this nominalism-realism debate, it makes a little more sense. One shouldn't multiply entities needlessly. Well, who's multiplying entities? Aristotle sure is. Well, the world is full of these extra things, like there's redness. And how many other colors? I mean, there's periwinkleness, and there's taupeness, and there's burnt sienna, and there's all these other colors and all these other properties. Lots and lots of entities in the universe, in the world of a realist. And William of Ockham is saying, no, you shouldn't just make stuff up like that. Of course, it's a question whether it's needless, but the Occam's razor starts to make a little bit more sense when you see the context it came up in. So, remember, Heraclitus was emphasizing change, Aristotle was a realist about universals, and Occam said that properties or universals are just mental concepts, right? Not real things at all. Which gets us to a contemporary. This is a guy who died within the lifetime of probably everybody in the room. W.V.O. Quine. He was born in 1908 in Akron, Ohio. If you know the U.S., it's a good place. It's just not like a cool place. It's not like, Ephesus, right? Surrey. And then there's Akron. Anybody from Ohio here? Okay, here's a trick. Here's how you can tell if you're in the U.S. in a big group. If you want to find the people from Ohio, if one person says, OH, the other one, some other Ohio person will say, I-O. I just learned this recently, and I've lived in the U.S. my whole life, so O-H-I-O. Anyway, if Quine were here, one of us could say O-H, he'd be like, I-O. Anyway, Harvard educated and a professor of philosophy at Harvard for his whole life. And he was focused on a lot of interesting things. By the way, he is an absolute paragon of what we call an analytic philosopher. And if you don't know what that means, I recommend that you look it up on Wikipedia later and read about it. Super fascinating. I won't go into detail, but that is a philosophical school that came to power during the 20th century and basically still rules Western schools of Western philosophy these days. I say that like it's a bad thing. Don't think it's a bad thing. It's just kind of the way it is. Anyway, he concentrated on philosophy of science, philosophy of mathematics, and of course, as a philosopher of the 20th century, had to think about philosophy of language, because that's kind of what we've been doing for the last 100 years. He is also a paragon case of a nominalist. Some people describe Quine as a radical nominalist, which does not mean that he sets the buildings on fire that are occupied by the realists. It does mean this, though. It says he started off thinking that, you realists, and by the way, this guy is a giant. He's not Aristotle. He might be William of Ockham, just kind of impact-wise. So in 800 years, we might still think of him as much as we think of William of Ockham, but absolute, hugely influential guy. So anyway, he observed that you realists have a lot of things, right? Like, again, all the different colors. And what are other properties? I have like a certain height. I have a certain weight. I don't know. I have some Swedish descent. I have the property of having some German in me. Like there are all these properties all over the place. All these properties. And he just observed, wow, you realists have, your universe seems overpopulated. And he's not the only one to have said that. And Quine said metaphysically he prefers a desert landscape. And again, he's not alone. So ultimately, where Quine ended up on this was that, if this could be, I'm doing a lot of unfair summarizing just by necessity, and this could be a little unfair, but the way I've read this is to say that there are things out there, like that you're there, I'm holding a clicker, there's a bottle of water and it's cold and all that, that's kind of bold talk, right? What I know is that impressions are presenting themselves to my mind. I see something about a bottle of water, I can hold it, and I form a concept of there actually being a thing here. But whether there's a thing here and it having properties and those things existing, I don't know, that's a little bit bold. All I know is that my mind perceives stuff. So that's radical nominalism, is that events happen to me and I form concepts of them. I don't know if those concepts are real or whether those things are really there. I just know about the events. Like the event of drinking nice cold water, I like it. So it's really for Quine, and maybe Thanos, I don't know about Thanos, but for Quine, it's about the events, not the entities. And that's important. That language sounds a little closer to home. As an aside, just kind of for fun about Quine, because a lot of you have probably heard of a program called a Quine, right? Anybody familiar? Hands if you know what a Quine is, or at least have heard it. Okay, not good. So there'll be a little bit more here. So Quine, the philosopher, was preoccupied with questions of self-reference, right? And self-referential statements there are often interesting paradoxes that arise there. Like this one, the statement yields falsehood when preceded by its quotation. So it's in quotation marks right now. Quote, yields falsehood when preceded by its quotation, end quote, yields falsehood when preceded by its quotation. That statement is false. So when you actually make the statement true, that is, you precede it with its quotation, it becomes a false statement. That's an example of a self-referential paradox. There are lots of them. And it's an interesting thing. Quine was preoccupied with this. So I don't know who was the first person to name a program a Quine, but a program, a Quine, is a program which takes no input and when run, reproduces its source code as output. All right, so it outputs its own self. For example, the shortest known Python Quine is here. You could take a picture of that and run it in a Python interpreter later, and if you type that in, it will print exactly that. I think the Python, minimal Python Quine, I think is the best, the best I've seen, the shortest I've seen, and kind of like most comprehensible. If you know some Python, you can kind of wrap your mind around that. The shortest known Ruby Quine it's got to be a one-liner, unfortunately, for it to work, and it's a little harder to photograph, but that's it. You can Google it, just shortest Ruby Quine, it'll show up. But yeah, you can run that at a Ruby REPL, and it will print itself out, which is kind of cool. And there are Quines in all kinds of languages. There's a Java Quine. That's a little bit harder to do in a typed language like Java. There is a Quine in this esoteric language whose name I will not speak. Maybe you're familiar with it. If you're not, too bad. But that is an executable program in a strange language that produces that output. So I just thought I'd include this just because Quine is this massively influential 20th century philosopher, and also we have this kind of program named after him. And another interesting thing, this is for another keynote some other time, but Quines, the programs, don't really do anything, right? Like, what do they do? Most of the code we write for money, tools, right? We write tools for businesses to do stuff. Quines are kind of like art. They do not have utility. You cannot take them and do a thing with them that will make money. Maybe you could perform one. You could pay someone to, or you could have someone pay you to live code Quines, but you can have people pay to perform art as well. So Quines, it's an interesting little subset of software because it is much more like art than tool building, which is most of what we do. Anyway, Quine himself, I'm going to say, wasn't sure there was a world out there. And it's not like he was some kind of bad guy. I'm not trying to paint him as strange or anything like that, but he was a radical nominalist. And he knew that there were events. Entities, not so sure about entities. He likes the desert landscape. He and Thanos like a universe relatively devoid of entities. So, summarizing. Heraclitus saw that events dominated. Things didn't matter, changes mattered. Aristotle thought about change, he thought about things, but what kind of comes out of Aristotle, what we seem to talk about the most, is this framework in which things could belong to types, or properties could belong to things. Individual things could have universals in common. These two guys, Occam and Quine, said, I don't think so. I think there's really just individual things. And I think Quine a bit more radically than Occam. Which brings us to this conflict between events and things. We have events, we have things. And not just things, but things that have something in common, or I'll just say, to be a little bit informal, things of the same type. Let's bring up a very simple software architecture diagram. A lot of us are building this right now. We take a perfectly good program and we break it into pieces and we deploy and execute those pieces independently on independent machines, right? This is some fictional e-commerce system where somebody can order something, we can ship it, and people can update their profile. That's what our system does. But of course, those pieces need to talk. Once we break up a perfectly good program into pieces, we need to reintegrate those pieces somehow. And we found out probably a few years ago that having them talk through a database was a bad idea, right? That's not usually a successful pattern or a successful path to integrate microservices. What it is, I think, is all Aristotle. It's all entity, it's all thing, and no Heraclitus. Frankly, we could discuss this sometime. It might be all Plato, really, more than Aristotle, but that's a discussion for an after party. So anyway, integrating through a database, probably a bad idea, and that is the entity-focused approach. We'll talk more about databases and entities in a minute. We could also kind of take an all-event approach. We could go to the other extreme. We could kind of go Quine and say, really, all there are is events. And this is actually nice. There's a lot about this that's good because, orders come in from my web front end, my order service validates them and writes them to a log. Say that's a Kafka topic. It would be a convenient place to put it. And now I've got this durable, replicated, immutable log of events. And that's nice. If kind of with Quine, I say that events are what there are. I don't even know if there are things out there in the world, but I know there are events. That inspires something healthy in an architecture because now I have a record of those events. And I can do things like stand up a shipping service that can consume from those events. And those are coupled asynchronously, and that gives me all kinds of resiliency properties in my system. We'll come back to that. And it gives me the opportunity to build other services other than shipping that I don't want to show on the slide, that I can't even think of yet. But if I have a log of events that have happened, that's nice. I can now process those events in different ways. I can reinterpret them according to other interests. I could do fraud detection. I could figure out who has bought enough that they need to be a part of my high status customer MVP program. I can figure out who I should send an alert to on their mobile app because they just bought something that relates to a store they just went, whatever. I don't even know what kind of things I could do. Once I've got a log of events, lots of different services can emerge there. But the problem here is that a lot of services, it's trivial to decompose services functionally, because I've written words there like users and shipping and orders, and you get it. I don't need to explain what I mean. It's easy enough to break things down functionally like that, but certain of those things, say like shipping, to perform a shipment, I need to know where to ship it, and that's over here. And so like this user service has access to some facts that shipping needs. Shipping also needs access to some order facts. So cool, I can consume those events that the order service produces, but I also need to know about things. It's not just events that the order service have produced that motivate me to work, but there are also entities that kind of pop up from under the covers and are there winking at me. There are still facts about things in the world. So this might be sort of the Occam-Quine inspired architecture, but there is a problem here. Let me maybe back up and refactor this system a piece at a time to show you the tension between these things. So here we have a fairly conventional microservices system. And if you work in retail, I know it's sort of adorable for me to show 3 services. There's the orders service and the shipping. You probably have like a dozen services involved in shipping. I get that. But for purposes of illustration, this might be how we would build an RPC integrated microservices estate, right? With just these 3 services. Events come into the orders service, it stores them in a database that's local to it, and then it calls the shipping service, and the shipping service remembers that. It calls the user service, which returns an address and sends that back to shipping service, and everybody's able to do their work, right? That's the RPC only situation. This, of course, is prone to failure cascades. If users goes down, then shipping can't get data from users anymore. And if that means shipping will go down, and if shipping goes down, we're going to have to build in a bunch of fault handling into orders to make sure it doesn't die on shipping. So it's, when you get call chains in an RPC integrated microservices system, you can get failure cascades. And service discovery is harder here. Service discovery maybe never completely goes away, but it's a lot more work. This is kind of like the worst case for service discovery. So I could refactor orders to shipping. We saw this earlier. That's simple enough. Now I just produce orders to that topic. Those are events. Shipping gets those and knows what to do and makes a synchronous call out to orders still. So those entities are still being stored here. Users is still this kind of entity-only approach where now shipping and orders are able to be an event-only approach. We recall, this is evented shipping, that users, or rather shipping needs to share facts with users. So when we take that RPC call out, what happens here is when you go to update your user profile, you want to go change your address. That posts some piece of JSON there saying, hey, I changed my address. The user service now posts that as a message to a Kafka topic. That message is simply saying, hey, the person with this user ID now has this profile. The shipping service in the middle is able to consume from that topic, just like it consumes from the orders topic, and materialize its own copy of that data. It can have a copy of that data. Why is it okay for it to have a copy of that data? Because the system of record is this immutable event log. We've kind of internalized the insight that events are first, and events are the thing that happens, kind of following Heraclitus. They are the thing that happens to us, and they're immutable, and we're going to remember them. But also, we have this insight that there are things in the world. The world is not just this stream of events that we take one at a time and we don't draw any conclusions about, or if we do draw conclusions, they're only mental concepts. There are really actually types of things out there. And this is really, frankly, following Aristotle and his more robust view of universals, that there are actually things in the world that exist. We find that we have to honor events. So, yeah, there's Mr. Heraclitus. He says, I told you, events mattered. And if we look at that crazy little database and that crazy little database, those are actually materialized views built up in memory of this immutable event log. To make that work, what has to happen to make that work? We have 2 independent programs that need to agree on the type of stuff in that bottom topic, this topic right here. That is, the things in that topic need to have some common set of properties. They need to have a shared schema. And a shared schema is a very realist concept in this metaphysical sense. You can't really have a schema without being a little tiny bit of a realist. And those things, in this case, it's like Plato is happy when he sees this. They actually live somewhere. Those schemas live, and by the way, people have solved this a lot of different ways. I always think of Yelp. They were an early Kafka adopter, and they built their own schema registry before there was a community one. Now there is a free thing called the Confluent Schema Registry. That's this service that runs outside of Kafka, and it actually talks to the client that writes messages and the client that reads messages, and maintains a database of these literal schemas. When you have a new type, you've got, say, some Java class that you've defined. This is what an order is, or this is what a user is. That gets serialized, and a unique ID gets created. It gets written into that thing up there. Actually, a Kafka topic, not really a database. That actually remembers the type of the stuff that's in the topic. You don't get a lot more realist than that. This way, one service, the user service, can create an entity, and another service, like shipping, can materialize a view of it, and they can agree on the type of the thing that's in there. Because those two particular services are accessing the same universal. So we have an architecture that, on the one hand, seems to draw inspiration from Mr. Change, Heraclitus, seems to draw inspiration from a guy like Quine, who says that, hey, life is just this stream of events that are hitting your brain, and you're forming concepts about it, but also has this very Aristotelian, very realist view of what's in it. When you design a system around a database, you do start by thinking about entities, right? This is where we all come from. You start designing a schema, you ask, what is there? You don't ask what happens. You ask, what is there? And this has worked for us. When you switch to event-driven architectures, you start thinking of sequences of events. What does my service consume? What events does it produce? What other services want to consume those events? We take this very, very event-centric view. Yet, there's something in there. That key value pair has a structure, and the structure of those events remains important. And a lot of people are building things like this, and this is a Kafka thing, building systems on Kafka, and you can very much see the tension between thing and event being worked out in the minds of these architectures. And you can see on a community basis that the community has produced tools like the schema registry and like features of Kafka or Kafka streams, K-tables. These are whole abstractions in an API that are built to solve this problem. Now, does this tell you that realism is true or nominalism is true? It in fact does not. And one of the great things about philosophy is that's not how it works. Now, 1,000 years ago in Europe, realism was absolutely assumed, and you would be considered a weirdo, and maybe you wouldn't make friends if you were a nominalist. Or really the idea 1,000 years ago wasn't even really fully formed. 800 years ago, you'd be a little bit sketchy, and maybe people don't want to be seen with you. These days, there certainly are practicing realists who publish and write books and things like that. But nominalism to us, once I laid those ideas out, nominalism seems like the plausible thing. That's just how it works. One of the cool things about philosophy is that it takes really trivial questions, simple questions like, what kind of things are there? What is there in the world? And it gives you answers that are so complex that you're just barely able to understand them. It's kind of cool. So none of this really answers this question. This is a debate that's going to go on. And it frankly makes event-driven distributed systems development seem downright trivial by comparison, which is nice. If it's a thing that you do, you realize there are things that are a lot harder, and maybe your life in refactoring to microservices isn't as bad as you think, and you could be a philosopher instead, which would be much worse. But really the point I want to leave you with is that The craft, the part of our craft that we are refining right now, this problem of, as I said before, splitting a perfectly good program up into pieces and versioning and releasing and evolving those pieces independently and scaling them independently, and learning how to manage complexity, change, and scale in software well. We're kind of getting that figured out over the last, I would say, 5 years. That whole process that we're going through as software developers and architects is drawing on an intellectual tradition and a set of controversies that are as old as the Western intellectual tradition itself. So, don't feel bad if it seems hard. Thanks. Have a great night and a great day tomorrow. Rest up, because you got a lot more work to do tomorrow.